Solving inequalities is a lot like solving equations. There is only one big exception for which you need to be aware. Equations, hey, if we got this one here, we want to get x by itself, just add 3 to both sides. Just add 7 to both sides. Life is fine. We solve the inequality. But there is one big exception, and it happens when x is either being multiplied by a negative or divided by a negative, or whatever variable, not just x. But we will do what we normally do in an equation to solve. We'll divide both sides by -2, but here's the dilemma. This side will give us an x, this side will give us a -3. Now the trick is that we're supposed to remember that an inequality sign gets switched and becomes a less than sign in this case whenever you divide by a negative. But just because we remember the rule doesn't mean we completely understand. So an effective mathematician, leader, critical thinker is often asking the question why, and we should do that because success in advanced math really has a lot to do with the foundation that we build. So the more we can understand, the more we're going to make connections with more sophisticated ideas, and then we'll really know it. So it's worth it for us to explore why. So what we're going to do is plot some solutions to this inequality. And like we saw before, we know that at x equals -3 is where the boundary is, because we divided both sides by -2. But here's the question. Is it right to switch this to a less than sign, or should this be staying as a greater than sign when we divide both sides by 2 to solve this? Well, here's the thing then. We either have this as our final solution, x is less than -3, or this, x is greater than -3. So it's either this side of the boundary of -3 where all the solutions are, or it's that side. So, we're going to explore it. Let's plug in some numbers. There's our original inequality. We're going to put different numbers in for x. If this is true and the final solution should be all the numbers x that are less than -3, then let's pick a number below -3, like -4. Well, sure enough, when we put that guy in for x, we get that 8 is greater than 6. That's true. That implies that -4 is a solution, so we can put a closed circle at -4. Likewise, choose another number that's below -3, like -7. If we put that in for x, sure enough, we get 14 is greater than 6. True statement. Another solution at -7. Now let's go to the other side of -3. Let's try x equals 0. That's a good number to choose. That is in this range, that x is greater than -3. 0 is up here. But alas, if we put a 0 in for x, we end up with 0 is greater than 6. That's not a true statement, so 0 is not a solution. Let's try one more number on this side of the boundary, like 5. But again, -2 times 5 is -10. -10 is not greater than 6, so again, not a true statement. That side of the boundary, no solutions. This side, infinitely many. If we keep checking numbers on this side that are below -3, we'll find they're all solutions, all solid. So in the end, we just fill in and connect all those points. That's what the shaded line is. Infinitely many dots, solutions that are connected. Open circle at -3, because you can't put a -3 in there, because this is not a greater than or equal to sign. It is an open interval there. Alright, so we're starting to get this sense of why we should switch the sign, because we just went through that whole deal. But let's do this. The main reason why involves the fact that a negative times a negative is a positive. So for -2x to be greater than 6, -2x must become a big positive number. Now, here's the thing. A lot of algebra students want to just focus on the x and ignore the -2. Let's look carefully at what I just got done saying. Treat this as a whole quantity. That entire quantity, the -2 and the x, has to be greater than 6. This quantity has to return to us very big positive numbers. Keeping in mind then that that entire quantity has to give us big positive numbers, then we should ask ourselves, okay, within that quantity, when it comes to this variable right here, what should be the characteristic of x? Well, for -2 times x to become a very big positive number, the x values have to be big negative numbers, so that a negative times that negative is going to return for us a positive. That's why we switch the sign, because look at here. We're saying that x has to be less than -3. That's where all the big negatives are. So once again, treat this as an entire quantity. That whole quantity has to be greater than 6. Has to give us values that are above 6 on the number line. But for that to happen, the portion of this quantity that we don't know, the x value, that has to be a big negative. If you pick a big negative down here, like negative 100, if you put that in for x, that big negative being multiplied by this negative 2 will give you a positive 200. Indeed, that is bigger than a positive 6. So one more time, that green quantity, that whole quantity, has to return to you a big positive, a number greater than 6. That means that x has to be made up of all the numbers that are big negatives. Numbers that compared to the negative 3 are below negative 3. We find the big negatives below negative 3. That's why when we solve this problem, we say, okay, negative 2x is greater than 6. I divide by negative 2 on both sides. My x's have to be big negatives. They have to be less than the negative 3. That's why we're going to have to switch the sign. So if we want an algebraic statement to solve this thing, in class we talked about turn to your partner and say why. Why are you going to get the result that you get? Ponder that inequality just for a sec. Do the math, see what you get, and then reason it through. So what we're going to do is say I got to get x by itself. I have to divide by a negative 3. I have to divide this by a negative 3. This is going to give me x. A negative divided by a negative is going to give me 4. But I just divided by a negative, so I have to switch the direction of the sign, the inequality sign. So instead of less than, I need it to be greater than. Okay, that's fine. So our final answer is x is greater than 4. That means we need to choose x values that are really big positives because up here, this is an entire quantity. We need that whole quantity to be less than negative 12. We need this quantity now to give us numbers below negative 12. So we need our final results compared to negative 12. We need them to go down this way. So this quantity has to give us big negative results. So when we solve for x, it makes sense that the x's we put in have to be greater than 4 because it's these solutions where x will give us big positive numbers. When we choose a big positive number like 100 to put in for x, we get negative 3 times 100, and sure enough, that's negative 300. Negative 300 is indeed less than negative 12. That's why we switch the direction of the sign so that that quantity becomes a big negative. It only happens when that x would be a big positive. So if we practice these, be careful here, even though there's negative numbers involved, we never multiplied or divided by a negative, and so we leave the sign alone. Don't just be always flipping the sign. But here we go, we're going to divide by a negative, so the correct thing to do is to say x is no longer less than, x must be greater than this negative 4, because we have to put big positive numbers in here in order for this to be a big negative number that will be less than this 20. So it's a little bit trickier there. This guy, we multiply both sides by negative 2. We're multiplying by a negative, so we're going to switch the sign. This is going to involve us multiplying or dividing both sides by a negative, so we'll switch the sign there. So that's it. Always switch the sign when you multiply or divide by a negative with an inequality, because multiplying or dividing by negatives will switch the values to the opposites, and hopefully you understand why we have to do it. Review the video if you need to. Good luck.